This is video I11, and today we're going to study antiderivatives. And so we should probably first define them. Antiderivative. And here's a difficult to read definition. That's a capital F of x is an antiderivative of f of x, that's lowercase now, on an interval I, so from this x to that x, if the following is true. The derivative of capital F of x equals f of x for all x on I. But to put it simply, the function from which a derivative was derived is an antiderivative. So if we derive this, we would get the original function. Okay, and so we're basically just going to go backwards with all of our old derivative rules. And so question 1 is find an antiderivative f for the following. So let's say I have f of x is 2x, and we have to find its antiderivative. Very simple question. What could we have derived to end up with this? And I'll give you a second to think about it. And this looks like a power function. Capital F of x would be x squared, because we would pull that down, decrease it by 1, and get this. And so we'll see a pattern with the power functions. I think we've already seen this. And we'll come up with a general rule for antiderivatives. B. So if f of x is cosine of x, what is its antiderivative? Once again, what could we derive to get cosine? I don't think I need to give you much time to think of that. Hope you have it already. It's sine of x. Maybe a bit more difficult one. Okay, so what is the antiderivative? What could we derive to get this? And we have to remember that when we derive, we are allowed to derive term by term, and so we must be able to antiderive term by term. So it's just simply two separate problems. So what could you antiderive to get 1 over x? And the answer is not just the natural log of x, because I showed you something about its graph, and maybe you should go back into your notes and look at this when we first developed it. 1 over x has two sides to it. Its antiderivative would have to have two sides. We want it to work for all x on whatever interval we have here. And that's why when we antiderive 1 over x, we get the natural log of the absolute value of x. And what I was talking about, two sides, there are x's over here, but also x's over here. The natural log graph only exists over there, but the natural log of the absolute value of x will look like this. Okay, so that's this term. Okay, and then maybe a simpler term. Okay, so what could we derive to get this? Well, it's going to have to be something like e to the 2x, but don't trust yourself right now. Okay, try to derive these. See if you end up with that. And so if you think, what's the derivative of e to the 2x, you notice a chain. The derivative of e to the something is simply e to the something. That something isn't just x, so we multiply by its derivative and we get 2. Okay, and then perhaps if you were in the classroom, this would be one thing that would make us lose a ton of points this semester. So if we have an antiderivative of this function, then the general antiderivative, and we've talked about this already, but now it's going to be formal, of f of x. So if we had this function and we were anti-deriving and we wanted not just an antiderivative, if we wanted the general antiderivative, so that's all things that we could possibly derive to end up with that, that's where big C comes in. It's just some constant. Because remember, if we're anti-deriving and we get the antiderivative, we should be able to take this and derive it, go backwards, and end up with what we started with. And the derivative of this term, this constant, is simply 0, so it doesn't matter what number that is. We didn't need big C here because I was looking for an antiderivative, not a general antiderivative. And don't forget what this means is if we have that function and that function, they're separated by a vertical translation. So maybe this is big capital of f of x, this is f of x plus 2. If you derive this, you have the same slope for every x value here. And so the constant was inconsequential. So don't forget, big C is a vertical translation. So next time, we're going to start, this will be video I12. I'm not going to actually do this problem. I'm going to let you have a chance to try it on your own. This will be problem 2. And so just have to be careful with the wording. We're going to find a general antiderivative, okay, for f of x equals 3x squared. Okay, and then let's make that part A. Let's say part B, find the antiderivative. We haven't talked about this yet, so you'll have to think a little bit, where that's true. So think about what that means, and we'll start with this problem next time. Good luck.